Hey guys, welcome to question MM315 of the Maths Methods Fortify study guide. So, got this question, the graphs of f between negative pi on 2 and pi on 2, where f of x is equal to x sine of 2x and y equals k are shown here. So y equals k is simply just a straight horizontal line, and f of x equals x sine 2x is this curvy thing here. So let's call this f of x here. Awesome. Sweet, so part A, firstly, is a 2-mark question. And it says, find the range of values of k such that the equation f of x take k equals 0 has 2 or less solutions. Okay, f of x take k equals 0, less than 2, or less than or equal to 2 solutions. Okay, awesome. Give values correct to 3 decimal places. Sweet. So, where do we start with this? Well, we know that if f of x take k is equal to 0, then f of x, adding k to both sides, we get f of x equals k. Okay, so if f of x is equal to k, that means that our two functions are equal to each other, right? And when they're equal to each other, that means we have points of intersection, all right? So our points of intersection are our solutions and vice versa, right? So whenever we talk about the solution between two separate graphs, we're talking about the points of intersection between those graphs. So what we're actually talking about, when it says has 2 or less solutions, we're talking about has 2 or less points of intersection. Okay, so with this line here, at the moment, when it's at the very, very top and it's touching these two turning points here, we have 2 solutions, right? Two points of intersection. If we move this down at all, we're actually going to have more than 2. We're going to have 1, 2, 3, 4. Anywhere between here, we're going to have either 3 or 4 solutions, right? So we want the range of values of k for which there is only 2 or less points of intersection. So at the moment, we have 2 points of intersection at the turning points. So our first point of, or our first, thing to do is to find out where these turning points are. Okay, so we know that these are turning points. So our turning points occur at f dash of x equals 0, right? Where our derivative or our gradient is 0. Okay. So this is a 2-mark question, so I would advise using your CAS just whenever you can. So according to CAS, f dash of x is equal to 2x cos of 2x plus sine of 2x. Awesome. Now, f dash of x equals 0 when x equals, now this is according to CAS, so I would use my CAS for this. X equals negative 1.014, x equals 0, and x equals 1.014. Okay, so we can see that our middle turning point is 0. That's this bit here. So that's not the turning point we're looking for. So we can see that this is negative 1.014, and this is 1.014, right? Awesome. But we actually need to know the y value, right? Because that's our x value, but we need to know the y value of these turning points so we can work out what k is. So therefore, f of negative 1.014 is what we want to find. And that is equal to, according to CAS, 0.910. And f of 1.014 is, of course, as well 0.910 because they're at the same height. Awesome. That's our first mark right there. So that means that this distance here is 0.910. Right? Because this is 0.910 there, and this is 0.910 there. Awesome. So we know that when k is equal to 0.910, it has 2 solutions, 2 points of intersection, right? But we also want the range of k when there is less than 2, all right? So here and above, it's going to be less than or equal to 2 points of intersection, right? Because here we have 2, and then as soon as we move it up, we have 0, which is, of course, less than 2. So our first range is k is greater than or equal to 0.910, right? So that's our first thing. Our second thing is below the graph, right? Because if we move this k line down past the x-axis, we're actually going to not have any solutions either, right? There's going to be no points of intersection here because this f of x graph stops on either side here at the axes. So that means that k is less than 0, right? We don't include 0 because if it was on 0, we would have 3. We would have 1, 2, 3 points of intersection between these graphs, which means that our final solution is, and I like to use interval notation as opposed to set notation. So from negative infinity to 0, not including 0, and so everything below here up to 0, and, or union, from 0, including 0.910, so 0.910 up to infinity. And that's it. So that would be our second mark. So we have less than two or less points of intersection from negative infinity to 0 and from 0.910 to infinity. That's your final answer for this part A. If you have any questions, let me know. I know that might have been a bit confusing, but just hit me up in the comments. Let's move on to part B now. Part B is simply a 1-mark question, which means we can use our calculator because we are allowed to use it in this question. So what I would do in this question is simply just plug this into your calculator. So part B says, let k equal a such that the equation f of x take k equals 0 has 2 solutions. And part I is 1 mark. Find d of dx of x cos of 2x. Awesome. Sweet. So I would just put this in my calculator. So menu 4.1 in your cas, chuck that in, and you will get dy dx, or I should say d dx cos of 2x equals cos of 2x minus 2x sine 2x. That's your first and only mark for that question. Of course, you could also use your product rule, do it by hand, but it is unnecessary now because it's only a 1-mark question, so you only have to show your answer. Cool. That's part BI. Let's move on to part BII. Part BII is a little less straightforward, actually a fair bit more complex. So that means that this is going to be a 3-mark question. So part BII, oops, II, 3 marks. Awesome. And it says, hence find the area of the shaded region above bound by the graph of y equals k and the graph of y equals f of x when k equals a, correct to 3 decimal places. All right, bit of a mouthful, but let's work through it. So first things first is to recognize that our question says at the top in part B, let k equal a such that the equation f of x take k equals 0 has 2 solutions, right? So if it has 2 solutions, the only possible place it can be is touching the 2 turning points at the top like that, right? That's the only spot that it can possibly have 2 solutions. Yeah, so 1, 2. So what we're looking for is the area between this, so the area between y equals k and f of x, all right? Which means that our area is going to be from our 2 intersection points, which is negative 1.014 and 1.014. Now we know that because these occur at the turning points, which is, like I said, where k is when it has 2 solutions. All right, so we know that we're using these terminals. Sweet, so from here, we know that the top graph is our y equals k, so we say k there, minus our bottom graph, which is f of x dx. Fantastic. Now, our only problem is that f of x is equal to x sine of 2x, right? And we don't know how to integrate this by hand. Now, we have our calculator in this question, which means we can actually just use our calculator. In the work solutions, I've put the complete working for integration by recognition with this method. So you can check that out if you want to, but here I'm just going to use my CAS. So here we have our negative 1.014, 1.014. Now, k, when k equals a, is equal to 0.910, right? So we get 0.910 minus x sine of 2x. Awesome. Nice. So that's our first mark. And we can, like I said, plug this into our calculator, as in just this bit to get the integral. And what we end up with is 0.910x minus 1/4 sine of 2x plus 1/2 x cos 2x. From, hopefully you can see that, from 1.014 to negative 1.014. That should be a 1,4. Awesome. That's our second mark. So there is a fair bit of working that can go into this, and it all comes from part BI, right? So when you find that derivative, you go into the integration by recognition. There's many other videos that I've done on integration by recognition, so check those out if you're not too sure. Otherwise you can check out the work solutions as well. So therefore our area is going to be equal to 0.949 units squared, which gives us our third mark. Now this is our final answer for this question, or for this part I should say. If you have any questions about it, let me know. Otherwise you can search through this playlist that this video's in, and you'll be able to find integration by recognition questions. Awesome. Let's move on to part CI. Part C is simply a 1 mark question, but it does introduce a new, not necessarily a new concept, but a new line into this. So we're saying in part C, which is a 1 mark question, part CI I should say, let k equal 1/2 as shown below. So we're actually inserting a line into here with 1/2, and part I says find the values of x for which f of x equals 1/2, correct to 3 decimal places. Awesome. So what we're talking about there is where f of x equals 1/2 are the intersection points between these two graphs. So it's just a 1 mark question, so we can do this in our CAS. So what I would say is solve in CAS. 1/2 equals x sine of 2x, and therefore, well, actually where x is between negative pi on 2 and pi on 2, so therefore x is equal to negative 1.386, negative 0.557, 0.557, and 1.386. And that's it. So that's our first mark and only mark for this question. Pretty straightforward question, really just to get you used to using your calculator and kind of just give you a question like that. Awesome. Let's move on to part CII. Part CII challenges us to find the area of this shaded region here. So we're going to have to use our laws of symmetry here as well. That's going to be a big part of this. So this is a 2 mark question. Awesome. So the first thing to recognize is that this graph is symmetrical around our 0 line, right? So this side is exactly the same as this side, which means in order to find the total area of the shaded region, we're going to find this area, and then we're just going to times it by 2. Okay, so that means that this area here, so area 1, let's call it, is equal to our from here to here under our f of x graph, right? So we're doing this section, then we'll do this section, then we'll do this section here, from here to here. So our first section here, this area, is going to be from negative pi on 2 to our point of intersection of the y equals half and f of x, right? So in the previous question, we found this was going to be negative 1.386, and this one here is negative 0.557. There are x values at those points. So from negative pi on 2 to negative 1.386 of f of x, which is x sine of 2x dx. Then we're going to add this area here, plus, I'm not going to have enough room, so I'm just going to do it below, from negative 1.386 to negative 0.557 of 1/2, right? Because that's the function that we're dealing with. The area under that actually has nothing to do with f of x at the moment. Then plus from negative 0.557 to 0, right? So we're looking for this area now, because we're going to add all these together, and that's going to give us the total area there. And then this is under the f of x graph again. So x sine of 2x dx. Awesome. So this is our first mark. Recognizing all that is our first mark. So then what we get is, I would personally evaluate each of these separately and then write them out just so that we don't lose marks for not doing enough working. So then we get 0.0487 plus 0.4146 plus 0.1016, which gives us 0.565, and that is our area 1, which is this shaded bit here. But that's not completely what we're after. We're after all the shaded area, okay? So we're going to get this, multiply it by 2, and that's going to give us our total area. So area total is equal to 0.565 times 2, which equals 1.130 units squared. And that's to 3 decimal places, which is what the question's asking for. So that's our our second and final mark. And that's our final answer for this question, for this part, and for this question, MM315. Guys, if you have any questions about any of this, please hit me up in the comments below. But otherwise, thank you so much for watching, and I'll see you in the next video.